We are finally about to witness history. A new star will explode in the sky, appearing green to the naked eye. This is a once-in-a-lifetime opportunity for our generation. The star, located 3,000 light-years north of us in the constellation Corona Borealis, T Coronae Borealis, is expected to explode in 2024. When it does, a bright star will suddenly appear in the night sky, visible to people all around the world. This is a rare astronomical event that 99% of ordinary people have never seen because currently, this star is too faint to be seen with the naked eye. However, when it explodes, it will become almost as bright as Polaris, the North Star, and is expected to last about a week before fading away. Many people might say this is another false alarm since predictions of star explosions have often turned out to be wrong. But this time, it's different. Scientists are very confident in their prediction because T Coronae Borealis is not a core collapse supernova, it's a nova or recurrent nova explosion, which occurs with a certain regularity. To understand what a nova is, we first need to understand how white dwarfs form, as novae are directly related to white dwarfs. We know that when a star's mass is between 8% and 40% of the Sun's mass, it is classified as a red dwarf. Red dwarfs undergo nuclear fusion at an incredibly slow rate, taking millions of years to fuse hydrogen into helium. When such a star dies, it does not explode but quietly turns into a white dwarf composed entirely of helium. However, red dwarfs have extremely long lifespans, sometimes lasting tens of trillions of years. To put this in perspective, the current age of the universe is only 13.8 billion years, so there are no such helium white dwarfs in the universe yet. On the other hand, if a star's mass is between 40% and 8 times the Sun's mass, it can begin fusing elements like carbon, oxygen, neon, and magnesium after exhausting its core hydrogen. When such a star dies, it leaves behind a white dwarf composed of carbon and oxygen and blows off its outer layers to form a planetary nebula. These stars have shorter lifespans, typically ranging from billions to tens of billions of years, so the white dwarfs we see today are made of carbon and oxygen. White dwarfs are about the size of Earth but have a density millions of times greater. They are supported against gravitational collapse by the electron degeneracy pressure, a quantum mechanical effect described by the Pauli exclusion principle. However, this pressure has its limits. When a white dwarf's mass exceeds a certain mass limit, knowing of the Chandrasekhar limit which is equivalent to 1.4 solar masses, its core undergoes runaway nuclear fusion, triggering a type of supernova explosion. But how does a white dwarf that is initially below the Chandrasekhar limit gain mass? Most stars in the universe are part of binary or multiple star systems. A white dwarf often has a companion star, and due to its high gravity, it can accrete material from this companion. If the white dwarf rapidly accumulates mass and reaches 1.4 solar masses, its core will reignite carbon fusion, leading to a type Ia supernova explosion. However, if the white dwarf gains mass more slowly, it can develop a dense hydrogen atmosphere. When enough hydrogen accumulates, it ignites in a thermonuclear explosion, similar to a hydrogen bomb. This causes a nova explosion, where the star brightens dramatically. After the outer layers are blown off, the star dims, but the cycle can repeat if the white dwarf accretes more hydrogen. There are a few recurrent novas with very short cycles, but typically, we don't often see a repeated outburst in a human lifetime, and rarely one so relatively close to our own system. T Coronae Borealis is a recurrent nova of this type. It was first discovered in 1866 when it suddenly appeared and became one of the 100 brightest stars in the sky. It exploded again in 1946, about 80 years later. Scientists predict another explosion this year, and even in light-polluted cities, it should be visible to the naked eye. The T Coronae Borealis, also known as the Blaze Star, is actually a pair of stars located 3,000 light-years away. As the last recorded outburst from T Coronae Borealis, which includes a hot, red giant star and a cool, white dwarf star, was in 1946, according to the NASA Space Agency, which forecasts it will do so again before September 2024. In recent years, scientists have observed that T Coronae Borealis has become more active, producing more X-rays, similar to the period before its 1946 explosion. Although the exact timing of nova explosions is hard to predict, scientists believe it will occur sometime between April and September of this year. We have discovered about a dozen such recurrent novae in our galaxy, such as RS Ophiuchi, which has a cycle of about 20 years, and T Scorpii, with a cycle of about 10 years. However, these novae are much fainter than T Coronae Borealis. This upcoming explosion will be a rare chance for us to see a nova as bright as Polaris with the naked eye. If we miss this, we might have to wait another 80 years for such a spectacular event to eye in the future. If we can witness a core-collapse supernova explosion with the naked eye, our generation will be incredibly fortunate. That's all for today's content. Stay curious, and I'll see you in the next video.